Ever stop to think about how you're using technology that's like a bazillion years old every time you use numbers?
It's true. What we take for granted now, like the ability to represent any number with just 10 symbols, was once a huge hurdle for early civilizations.
It's incredible how something we learn in elementary school, like the basics of counting, can have such deep roots in human history.
Absolutely. And that's what we'll be exploring in our deep dive today. We'll be using this fascinating textbook chapter, Knowing Our Numbers, as our guide.
So we're talking about like place value and all that. That stuff always seemed kind of basic to me.
It might seem simple on the surface, but place value is actually a really elegant and efficient system. It's the reason we can represent such massive numbers.
Okay, that's true. I never thought about it like that. So how did people handle large numbers before this system? Did they just like not?
Well, they had their methods. The Romans, for example, used a system of letters and symbols.
Oh, right, Roman numerals.
Right.
Like I, V, X, L.
Exactly. And while the Roman system worked for them for a while, it had its limitations. It made working with really large numbers quite difficult.
I can imagine trying to do long division with Roman numerals sounds like a nightmare. So this place value thing, it's like the key to unlocking the universe of numbers.
You could say that. It revolutionized mathematics and paved the way for all sorts of advancements in science, engineering, and beyond.
It's incredible how something so fundamental can have such a ripple effect. And speaking of different ways to represent numbers, did you say that not everyone uses the same system?
That's right. Our Knowing Our Numbers source points out two main systems in use today: the Indian and international comma systems.
Comma systems. That sounds kind of confusing. Don't we all just like put commas where they belong?
You'd think so, wouldn't you? But it turns out there are some key differences, and those differences can have real-world implications.
Okay, now you've got me intrigued. What's the deal with these comma systems? Tell me more.
Well, the Indian system uses commas to mark thousands, just like the international system. But then it gets interesting.
How so?
Well, after thousands, they use a lakh, which is 100,000, and then comes a crore, which is 10 million.
A lakh. A crore. Sounds a bit like something out of Indiana Jones, haha.
Right. Imagine trying to negotiate a business deal with those numbers flying around.
Talk about a recipe for miscommunication. So what about this international system? It sounds way simpler.
It is, relatively speaking. The international system uses commas every 3 digits to mark thousands, millions, billions, and so on. It's a system most of us are used to.
Right, commas every 3 digits. Got it. But still, having these two systems running around seems like a recipe for confusion.
It can be, and it highlights how deeply ingrained our number systems are in our cultures. What seems obvious to us might seem completely foreign to someone else.
Our textbook gives a pretty stark example of this. The number 5,008,001,592 in the Indian system looks totally different in the international system. 50,801,592. Same value, totally different vibe.
Precisely. And it's not just about aesthetics. Imagine misreading a financial report or a scientific study because of a misplaced comma.
Oh, wow. Talk about a costly typo.
Exactly. That's why it's so important to be aware of these differences, especially in our increasingly globalized world.
So we've gone from counting on our fingers to these massive numbers, commas flying everywhere. But how often do we actually encounter quantities that big in real life?
More often than you might think. And that's where estimation comes in, a skill we often underestimate, but as our Knowing Our Numbers source emphasizes, use constantly.
So it's not just about like rounding off numbers. There's more to estimation than that.
Think about it. How many people are in your city? How many grains of rice in a bag? We're estimating all the time without even realizing it.
Right. I guess you're right. The textbook even had those news snippets like estimating storm damage, understanding population growth, even the sheer number of passengers on a train. That's a lot of estimating.
It's about recognizing scale, seeing the bigger picture, even when we don't have the exact numbers. And sometimes, to make those mental leaps a bit easier, we use a handy trick: rounding.
Ah, rounding. Our trusty Knowing Our Numbers guide dives into that too.
Yeah.
Rounding to the nearest 10, 100,000.
Yeah.
It's like mental shorthand for massive numbers.
Precisely. Rounding simplifies things, making quick calculations or double-checking a breeze. But, as the book cleverly points out, it's not always the best tool for the job.
Right, like when you need absolute precision. I can't imagine rounding up a medical dosage. That's That's a recipe for disaster.
Exactly. And speaking of needing things to be exact, remember that brain teaser in our source material with Seema and Mira buying notebooks? Trying to figure out the total cost got a little complicated.
Oh, yeah, that's where those brackets came in. They always seemed a bit mysterious back in school.
Brackets are like the punctuation marks of math. They bring order to the chaos of numbers, making sure we all arrive at the same answer. Our textbook actually hints at this bigger concept called the order of operations, which dictates the hierarchy of mathematical operations.
Order of operations.
Yeah.
That rings a bell. PEMDAS or BODMAS, right? It's amazing how these little rules underpin everything we do with numbers.
Absolutely. Without those rules, we'd have mathematical mayhem. Imagine trying to calculate a discount at a store without brackets. Utter chaos.
So brackets are essential for clarity and precision. It makes me wonder if our current system is so sophisticated. What did people use before? Were they just stuck with, like, imprecise calculations all the time?
That's a great question. And it leads us to a fascinating detour in our numerical journey. Roman numerals. You know, those grand structures and epic battles of ancient Rome? Well, they were quantified using a system quite different from our own.
Oh, right. The I's, V's, X's. It's incredible to think they built an empire using a system that seems so, well, limited compared to what we have now.
It's true. The Roman numeral system, while impressive for its time, had its limitations. And as our knowing our number source cleverly points out, those limitations played a crucial role in paving the way for the elegant and efficient system we use today.
So we're talking about the Hindu-Arabic numeral system, right? The one with 0 and all that. I have to admit, I kind of take it for granted.
You and me both. But the development of this system, as our trusty textbook explains, was a pivotal moment in human history. It wasn't just about new symbols, it was a whole new way of thinking about numbers.
Okay, now I'm really intrigued. What made it so revolutionary?
Well, while the Romans were busy with their V's and X's, a revolution was brewing in India. This new system had a groundbreaking concept, the zero.
Zero. But 0 is, well, nothing. Why was that such a big deal?
You see, that's the beauty of it. The concept of zero, of representing nothingness, was revolutionary. It wasn't just a placeholder. It opened up a whole new dimension in mathematics.
I never thought of it that way. But I can see how representing nothing would be pretty important.
Exactly. And it paved the way for negative numbers, which were crucial for representing things like debt or temperatures below freezing.
Wow. 0 really was a game changer. But how did this new system make its way from India to the rest of the world?
That's where our deep dive takes a fascinating turn into cultural exchange. The textbook talks about the spread of the Hindu-Arabic numerals through trade routes, reaching the Islamic world, and eventually making their way to Europe.
It's amazing how something as seemingly abstract as a number system could travel across continents and cultures like that.
It really is, and its impact was enormous. The textbook highlights how the adoption of the Hindu-Arabic numerals in Europe sparked a renaissance in mathematics and science.
It's like they were finally speaking the same language, mathematically speaking.
Precisely. Imagine trying to perform complex calculations or advance scientific understanding with the limitations of Roman numerals. It would be incredibly difficult.
It's like trying to build a skyscraper with just hand tools possible, but incredibly inefficient. The right tools make all the difference. So we've gone from counting sticks to these elegant systems, and it makes you wonder, what's next for numbers? Are we done?
It's a fascinating question. Our trusty textbook doesn't have all the answers, but it does make you think, could there be a better way to handle numbers?
You mean like a whole new number system? Is that even possible?
It might seem far-fetched, but think about it. Our current system was born from the needs and knowledge of its time, but now we're in the digital age, grappling with data on a scale people couldn't have imagined centuries ago.
So you're saying our trusty Hindu-Arabic system might be due for an upgrade?
It's not about replacing it, but maybe, just maybe, there are systems out there waiting to be discovered that can handle the complexities of, say, quantum computing or even the vastness of the multiverse.
Okay, now that's mind-blowing. I never thought of it like that. It's like we're constantly pushing the limits of what numbers can do.
Exactly. This deep dive into knowing our numbers reminds us that even something as basic as our number system has a history, an evolution. Who knows what the next chapter holds?
It's inspiring in a way.
Yeah.
We started with simple place value, then explored how cultures organize numbers differently, even took a trip back in time to visit Roman numerals. It all points to this incredible human desire to understand the world through numbers.
Absolutely. And that's something we can all appreciate, Even if we aren't mathematicians, next time you see a big number, take a second, just a second, to think about the journey it represents: centuries of human ingenuity, all leading up to that very system we often take for granted.
That's a great way to put it. Well, on that note, we'll leave you to ponder the amazing world of numbers. Keep those calculators handy and those minds curious, because there's always something new to discover in the endless world of numbers. Until next time.